right. Hopefully your test went okay. And we're going to look at, we're kind of winding down at the end. I'm going to try to get in as much as I can here at the end. But this one, I just want you to take notes over this material. I'm not going to have an assignment, but I do want you to take, well, there is going to be an assignment. You're going to upload your notes, but no problems to do. I just want to put this material on there. I'll probably also put a couple other videos on it just so that you have the information as full as you can. Please watch those. This is, I'm just going to give the basics of this so that you're aware of what these are, but parallel is one word that we're going to mainly look at with this. And mainly when we do with parallel, we're working with parallel lines. The parallel can be planes. There can be planes that are parallel to each other. Shapes can be, you can have columns be parallel to each other. So parallel doesn't just mean with lines, but that's mainly what we're working with. Parallel lines mean you have two lines that run next to each other, okay, and they can be further apart, they can be miles apart, but they run next to each other, but they never touch. And one key fact is they have to be on the same plane. And I'm not going to get too deep into that, but this board is a plane, okay? It's a flat surface, it's a plane. A street is a plane, it's a flat surface. You can have planes out in space, but here's what you don't have. You don't have a plane, you don't have parallel lines. Here, let's say I have a line out here and I'm holding it, but then out here I'm holding a line. These two lines run, they run next to each other. Here, this one's going up and down though, this one's going sideways. They are never gonna touch, okay? Because this one's out in space over here, this one's out in space over here. They're never going to touch, but they're not parallel. One of them's going this way, one of them's going up and down. So in order to be parallel means they have to be on the same plane and run next to each other and never touch, okay? They stay, when I say run next to each other, they stay the same distance apart. They never start going towards each other, okay? So that is what a parallel line is. And there's special things about parallel lines. For one is, whatever this measurement is over here, like if you have 4 inches or something, you're gonna know that down here it's gonna be 4 inches. Okay, so that lets you know some certain things. One way that they will mark parallel lines is they'll put these little filled in arrows, almost like markers, to let you know that those are parallel. Another way that they can indicate that lines are parallel is, let's say this is line A, or let me mark them. Let's say that's line AB, and this is line CD, okay? And they can say AB, okay, line AB, or segment AB even, is parallel. They're going to put these little parallel lines like that to CD, okay? So that's another way they will indicate that those are parallel. You need that information given to you because you can't just visually assume that two lines are parallel as you go in math. So you need that kind of indication that, hey, we're letting you know these two lines are parallel. Okay, so let's say I have two parallel lines, and you can have more than two. There can be 3 lines that are parallel to each other, and so on. So it doesn't just have to be 2. But let's say you have 2 lines that are parallel, okay? Darken this one in a little bit. So you have these 2 parallel lines. Well, there's another word called transversal, and that means a line that just cuts through those parallels. It can go that way, and go this way, and go straight up and down. It can go any way, but let's take one and cut through. That is a transversal, okay? That's what this line is. It cut these parallel lines and cut them. When that happens, what you can see has formed is 8 different angles, and they can be ordered in any way. They don't have to be 1, 2, 3, 4. It could have been 1, 2, 3, 4, 5, 6, 7, 8 that way. But as you can see, there's 8 different angles that have been formed. 1, 2, this angle here, this angle, and so on. And so with that, there's some special things that happen because these lines are parallel. You can have 2 lines, and you could cut it with a line, and you formed 8 angles, but if these 2 lines aren't parallel, these characteristics will not be true. It's only true on these where what happens is, because you've got 2 parallel lines, there's some special things that have in common with 2, and like 6 and 4 and 5 and so on. There's some special relativity to them. As far as the names, I don't want us to necessarily I'm not going to spend a lot of time when I'm naming these because we just don't have the time, but I do want to focus in on their measurements, what's special about their measurements. Now, one thing to cover is that you still have vertical angles there. 2 and 3 is still a vertical angle. Okay, 5 and 8 are still vertical angles. You know, if I'm looking at 2 and 3 alone, those are vertical angles. That is still the same. Like if 2 is 70 degrees, so is 3, because they're vertical. That has not changed from our prior lessons. Another thing is linear pair. You still have linear pairs. Okay, like 1 and 2. 1 and 2 still form a straight line here, and so they're a linear pair. They add up to 180. That has not changed. Okay, so those two things are still the same. A couple of the new ones are, first off, let me zero in. Let's call these like train tracks for right now. Okay, let's pretend these are train tracks that run parallel to each other. Inside the train tracks, okay, on the interior of the train tracks, these are called interior angles. Okay, inside. You know, interior means inside. Interior decorator decorates the inside of your house. These are interior angles. Okay, now let's take 3 and 6 in this example. 3 and 6 are both interior angles. They're both inside the train tracks, but they're on opposite sides of the transversal. Well, those angles are called alternate interior. Okay, they're on opposite sides of the transversal, but they're still both inside the train track. They are the same measurement. So if that one is 70, that one is 70. Another example of alternate interior on this one is these two, 4 and 5. Okay, and if that one's 120, then that one's 120, or 100, if that's 150, that's 150, so on. So that's what's kind of nice about these is, you know, and you can use visual looks, like that's a acute angle, and so is that. So those two match up. That's an obtuse angle, and those two match up. Okay. Then you have what we call consecutive interior. Okay. Consecutive interior are two. They're still interior, and they are on the same side of the transversal. So they're one right after the other. If you're looking down, it's 3 and 5, and 4 and 6. Now, if you notice 3 and 5, one's acute, one's obtuse, but what you're going to see is they're going to add up to 180. They're going to be supplementary. So they're going to add up to 180. Another example of consecutive interior is 4 and 6 here. Okay. Then you've got alternate exterior. Now we're not dealing with the interior angles anymore. We're dealing with the outside ones of the train tracks. And alternate means they're on opposite sides of the transversal here. So like 1 and 8 are alternate exterior, and 2 and 7 are alternate exterior. What's special about those is they're the same. So if that one's 120, so is that one. Okay. If this one's 50, so is that one. So on. Okay. Those are alternate exterior. The last one, let me redraw this. So I went 1, 2, 3, 4, 5, 6, 7, 8. The last one's called corresponding. Corresponding is a little bit harder to describe, but basically what it is you're going to have an exterior one and an interior angle, and they're on the same side. So like 1 and 5 correspond, or 6 and 2 correspond, or 4 and 8. One's on the inside, one's on the outside, and they're on the same side. Or 3 and 7. Okay, so those are corresponding. Like I said, I'm gonna put another video, I think, with this to kind of break that down. But the thing about corresponding is they add up to be the same. So what's nice is all these are the same. I'm just going to put same degree, and this one's same degree. Okay, the only one that adds up to 180 is this consecutive interior. So really, it's kind of nice because all these are same degrees. Now, what does this mean as far as what we're actually doing with it? Is let's say I've got these two parallel lines. I got this transversal, and let's say I, 1, 2, 3, 4, 5, 6, 7, 8. Well, all I need is one angle given to me. Let's make this, 70. Let's say that's 70 degrees. Well, now I can solve every single angle just from that one angle. And I have multiple ways I can do it. I can either say, hey, 70, the corresponding one is 70. Or 70, the alternate exterior with one is 70. 70, the vertical one is 70. I have multiple ways now that I can find these other angles. Now, what I would suggest doing is, because these are parallel, look for all the acute ones, if you have that option, and say, well, they're all going to be 70. Now, you have multiple ways that you can come up with that, but let's start with vertical. These two are 70. Well, here's my two acute angles this way. They're alternate interior. They're the same, so that's 70. Well, then I've got another vertical, and that's 70. Also, you can check that because the alternate exterior is 70, or the corresponding is 70. If you notice, I'm finding all the acute angles and marking them 70. Then I can go back to my linear pair knowledge and know, well, if that's 70, that's 110, because they got to add up to 180. Well, then I can go and say that's vertical. These are corresponding or alternate interior. These are vertical. So I can go in and fill in all the other angles. But if you notice, I knew all the acute ones were 70, all the obtuse ones were 110, and so on. So you have that option. But sometimes it gets a little hard if it's very, very fine, like maybe this one's 91 and this is 90, and then you got, 89. Then you got to kind of almost visually look and say, ooh, those are so close I can't tell. But most of the time it's going to be like this, where you can clearly see the difference, okay? So just keep that in mind. And that's kind of the crash course on that. So I wanted to do that. I'll put another video with that, but I want you to be able to see those and be able to see that you can solve all angles from just one of them given to you. The other thing I want to look at that's almost completely different, but I want you to take some notes on it, is some of the other shapes that we deal with. Triangles, we've really focused on triangles. And we're going to do circles later here in the next couple of assignments. But I wanted to hit one that's common, that's quadrilaterals. Quadrilaterals mean four sides. So you're talking about rectangles, squares, rhombus. They all have four sides. Trapezoids. Quadrilateral, and I get to spell again, okay, means four sides, and I think I spelled that right, meaning sides. I doubt I spelled quadrilateral right. But it has four sides. Okay, so that any shape that has four sides is a quadrilateral. Well, that breaks down a little bit more, where I can say, well, trapezoids, because they have four sides, but they're in their own category, and parallelogram. Parallelogram. There's that word parallel again. Now, these two are different from each other, but they're both quadrilaterals. It's like saying, I use the example cats, and now when I say cats, everybody thinks of that tiger show. I've not watched that, but it'd be like thinking, okay, cats, let's say, is the most generic name, or feline even, and then you can break that down to panthers and tigers. They're both cats, but they're separate, they're different. And then you can break that down even more. Maybe on tigers, you get into Bengal tiger, or on jaguar, whatever different jaguars, I don't know that many. So you can break those down. But a parallelogram, all that means is both sets of sides. So like a parallelogram could look like this. This is parallel to this side. This is parallel to this side. Okay. A parallelogram could also look like this. It's the same thing. This is parallel to this side. This is parallel to this side. That's a rectangle. It's a parallelogram. So on. Trapezoid, what's different about it is it only has one set of parallel sides. So it could look like this, meaning these two sides are parallel, but these are not. Or it could look like this, meaning these two sides are parallel, but these two are not. Okay, so that's what separates it from a parallelogram. Then under parallelogram, you could break down into rectangles. Okay, you could, now if it's just like this is just its own parallelogram. That's all it is. But if you get into a rectangle, it's very specific. Okay, what makes it specific is you have all 90-degree angles. Okay, so it's a parallelogram. Both sides are parallel, but they're all 90-degree angles. Over here, you have a rhombus. And just real quickly, mainly what we think about is like a kite kind of shape, okay? We'll stop there. And then to break this down even more, if you combine these two things, meaning the characteristics of a rectangle and a rhombus, if you combine them, you end up with a square, okay? And a square is a parallelogram still. It's still a quadrilateral, but it's the most specific, okay? It has all these characteristics in one. So that's kind of the best chart that I could do. And we know the special characteristics of a square. All the sides are the same, you know, and so I wanted to put that chart up there so that you had that knowledge and look over that. So take these notes, keep these for, you know, prior things. Where they, you know, I know when we took the final, you know, in the prior terms, they would give you like a TV and they would ask you, what kind of shape is this? Well, TV would be a rectangle most of the time if it's a flat screen that's spread out. It's a rectangle, but it can also be called a parallelogram or a quadrilateral. You can fit it in all categories of that. It's not going to be a trapezoid. Okay, very rarely. I don't think I've ever seen a TV the shape of a trapezoid. So you got to be able to classify these shapes in here. Okay, so I wanted you to have those notes as well. All right, so take the notes, upload the notes for your assignment for this one, and go from there. Okay.